In this lesson, we're going to be talking about radical expressions and radical functions, and this is going to lead up to our chapter on quadratic equations. We're going to experience more of this in completing the square and the quadratic formula. When we look at the square root of a number, our root is written in this manner, such as this. This is going to be read the square root of 25. And the question that's asking is what times what? Two different times. What times what is going to give us 25? Which in this case right here is small enough that we realize that 5 times 5 is 25. So as far as the square root of 25 is concerned, 5, positive 5, is our answer because this is written as a positive square root. So when we look at the square root of 0, we're asking ourselves what times what gives us 0, which is actually 0. If we had a fraction, you could look at the numerator and denominator separately. What times what is 9? What number times what number is 25? And so you would have 3/5 as your final answer. For a decimal, 0.6 times 0.6 would be 0.36. Most of these are simple enough to look at these in your head, but in this case, when we have a variable, remember our rule for variables is when we multiply variables, we add our exponents. So the question is, what plus what is going to give us 10, being the same number? So it would have to be x to the 5th power, because 5 plus 5 is actually going to be 10. And sometimes numbers and variables exist in the same type problem that needs to be simplified. The square root of 36 is going to be 6 because 6 times 6 is 36, but as far as the exponent is concerned, what plus what is going to give us 6, so that's going to be x to the 3rd power. When a negative sign is involved, it depends on where it's located. Is it on the outside of the radical, the inside, or if it's both? The negative sign happens to be understood -1 in the front. What you're taking the square root of is just 25, and we know that 5 times 5 is 25. The negative sign just happens to be out front. But if it's placed on the inside, we're asking ourselves what times what is -25. Well, there's nothing times itself that's going to give you a negative, because a positive times a positive is a positive, and a negative times a negative is a positive. So you'll never get a negative. So what happens is the square root of a negative number, an even root of a negative number, is actually an imaginary number. So we represent that with I, and then we take the square root of the number, which is going to be 5. Now, as far as homework is concerned, in this lesson, it'll probably just, as far as an answer is concerned, it's going to say not a real number. But when we get to later in this chapter, it's going to actually introduce the concept of I. So we're going to go ahead and write as I here. Now, on this one, if it's inside and outside, that does not mean take a negative times a negative and make it a positive. That's not what that's talking about. In this case, you're going to take the square root of -25. Well, the square root of a negative that we just saw earlier is going to be an imaginary number. The square root of 25 is 5, and we happen to have a negative sign out front. So each plays a different role, and you just have to take it in pieces. That's square roots. If it is a cube root, then we're asking ourselves 3 different times what times what times what is going to give us 0, which in this case would be 0 times 0 times 0. But like I said, it is going to be 3 times. The cube root of a negative number, now in the previous examples we could not take the square root of a negative number, but we can take the cube root of a negative number, because a negative times a negative times a negative is still going to give you a negative. And so 2 times 2 is 4, and 4 times 2 is 8. So that cube root would actually be -2, because if you multiplied it times itself 3 times, you would actually end up with a -8. Fractions are the same as with square roots. Take the cube root of the numerator, so what times what gives us 1, which is 1, and then the cube root of 64, the denominator, is what times what gives us 64, which is going to be 4, because 4 times 4 is 16, and 16 times 4 is 64. Again, with the variables and the exponents, you have to ask yourself what plus what gives you 9. In this case, it would be 3. Or you could say, how many groups of 3's, x's, can I take out of x to the 9th, which would be 3 groups of x's. The cube root of a negative number is negative. You can take odd roots of negative numbers, not even roots. The cube root of 64 is 4, and the cube root, or I can take 2 groups. If I had 6 x's, I can take 2 groups of 3 out, so that would be x squared, or you could say 3 divides into 6 2 times. And that would be your answer. And you could multiply this out to check the solution. Sometimes we have higher roots, and it'll just say, as far as instructions are concerned, find each root. So however many or whatever the number in the radicand is located, that's how many times you multiply. So you're going to say what times what times what times what gives us 16. And so it would have to be a small number just because if you're multiplying it times itself. So if you check out the number 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is going to give you your 16. So 2 is going to actually end up being the cube root of that 4, or the, excuse me, the fourth root of that 16. The fifth root of a negative number is negative. Again, you're asking yourself 5 different times, what can you multiply to give 32, which is actually 2. The fourth root of a negative, it's an even root of a negative number. That is imaginary, does not exist because you have an even amount of negative signs, which always ends up being a positive. So we're going to represent that with the I. The fourth root of 16 is going to be 2.